into these, I will explain in a minute here the last two on the what do you call it, the word problem stuff and how you set these things up. What does it mean to actually break even on something? How does that work in terms of actual money and things? Most of you guys haven't seen anything like that before, so how do you set it up? So we'll get to that. Now, the other ones, there are so many different ways of going about, ways about going about setting up and solving those systems of equations. There isn't always one way that always works better than another. A lot of times it winds up being up to you guys to decide what you want to do first. And there's really nothing wrong with that. What I tend to look for when I'm doing these things, and I think you guys remember when we kind of set up number 44 in class, is that I'm always looking for wherever I can find opposite signs. Anytime I see opposite signs, I know that I can add them together. That way I'm not worried about distributing negatives. I'm not worried about trying to subtract. I do better adding than I do subtracting because I forget to change my signs a lot. That's just my own personal thing because I know how I learned. I know how I was as a student, so I try to preemptively get ahead of where you guys screw up because I know where it's generally going to happen. So I think we started this one, didn't we? So it depends on which one you want to eliminate. If you want to eliminate the x's or if you want to eliminate the y's first. If you want to get rid of the y's first, you multiply the top one by 10, the bottom one by 7. That gets a common coefficient, and they would go away. If I wanted to get rid of the x's, I'd multiply the top by 11 and the bottom by 3. It does not matter which method you choose. If you math it correctly, you should, air quotes, get the same thing. So if we get rid of the x's, I would do that, and I would rewrite 33x, 77y, and 220, negative 33x, 30y, and a 15. Here's where it's important that you try something a little bit different. Yesterday I showed you guys when I do a lot of these things, I split it into 3 separate arithmetic problems by doing that, because then I'm reminding myself that I need to, in this case, add between each one of them. So I put a plus sign for all of them, because a lot of times what people will start thinking, especially with one like this, obviously I add these two together, they go away for the first group. The second one, you got the negative 70, those are heavy. You got the negative 77 and the positive 30. In your head, you're like, oh, I just subtract the 30 from the 77 and write it as negative. That's normally how students think, but then if you don't have this plus sign here reminding you, you might try to subtract here again. So remember, you're adding all 3 times. Okay? That's why I put in those things to remind ourselves. And I believe you get negative 5 when you math that out. Okay? Then, does it matter which equation you substitute the y back into? Yes, sir. If you math it correctly, yes. All right. So when you substitute that back in, if I go back to the second equation, I get the negative 11x. Then it'll be minus the 50 is 5. And x is also negative 5. So your solution set is always written as an ordered pair. That way we know that's how that works. Yes, sir?
Should we refer to the solution as an ordered pair for the last?
Not necessarily, because I think it was asking a specific question. I think it said like how much money or something like that, and that's okay. The idea of writing stuff as the ordered pairs comes into play a little bit more tomorrow when we start doing some shaded region stuff, because I'm going to start interlacing multiple sections at the same time so we can do feasibility regions. It's a lot of work. All right. Now, when you get going into some of the other ones, you start dealing with some funkiness, if you will. For example, this next one on 45, you've got a fraction you got to do, right? Well, if I'm looking at that, I'm seeing that I don't really want to deal with a fraction at all, because that's just, I don't know. and you could probably start to think this through in your head. If I multiply that top equation by 3, I get rid of the fraction, don't we? So if I do that first, I get x of 3y of 27. Now, what would I multiply the second equation by? Yes, sir. What would I multiply the second equation by to turn it into just a negative x? 1/2. You're still doing a linear combination here. It just so happens that this time the multiplier, that scalar, if you will, is a fraction. Because it's consistent throughout. All 3 terms in this thing are all even. By doing it this way, it just cleans it up quicker. You get negative x plus a y is negative 3. Same coefficient, opposite sign, and I add. Yes, sir?
So we could solve it without, could we like do other stuff to multiply?
Sure.
We don't have to do it 1/2.
That's fine. You did the top one by 6? Yeah, because then you get 2x, 6y, and a 54. As long as you just ripped all 3 parts, you're just doing a scalar. Because as long as however you see it, it's fine. There's nothing wrong with that. Absolutely not. Because here, I'm just going to get a scaled version of what you have. I'm going to get 4y is 24. I'm still getting 6. Okay? I still get 6. And then I'm still going to go ahead and throw that back in. I'm going to use the original equation. 1/3 of something plus 6 is 9. 1/3 of what is 3? 1/3 of what number is 3? 9. Or multiply both sides by the reciprocal. What's the reciprocal of a third? 3. And you get 9. So your ordered pair here is 9 and 6. Be very careful, especially if you solve for y first. Doesn't mean that it's the x coordinate, ladies and gentlemen. A lot of times students, since they solve for y first, they'll go, oh, it's 6, and then the second one, it was 9. Good times. What others of those did you want to see tips or tricks of different ways of maybe thinking about doing it than what I did versus what you did? What did you guys get for 47? Oh, I hear infinite solutions and I hear no solutions. Let's make sure we look at that so we can decipher the difference between the two. So, right off the bat,